Okay, so this week's lesson is about interpreting graphs. And what I want you to do when you're taking notes on this, I noticed a lot of you had issues with stage 3 of the classwork this week, which was drawing the trend of the graph and identifying the independent and dependent variable. So I want to make sure that this activity does help you in improving with those skills. So when you're taking your notes, I would like you to write down the statements A, B, C, D, and E, and leave some space over to the right-hand side on your notebook page for you to insert your graphs. But I also would like you to skip a few lines between the statements so that you are capable of writing some notes that demonstrate the characteristics of the graph. So that, for example, if you chose graph 1, you have some room to say, well, there's a horizontal piece in the center, which means that they could have taken a break or there was a pause in the data for some reason. And that's a characteristic that could help you identify what graph goes with what statement. Okay? So this first problem that we're going to do says, suppose a motion detector tracks the time and distance traveled as you walk 40 feet in 8 seconds. It says, match the following time distance graphs with the stories that describe each walk. Now, if we start out with our graphs, we have graph 1, 2, 3, 4, and 5, and statements A, B, C, D, E. Statement A says, you walk at a steady pace of 5 feet per second. Now, walking at a steady pace, once again, that means that the distance that you're walking and the time that you're walking is consistent throughout the data. So for every second, they're walking 5 feet. This tells us that our line is going to be a straight line. So the only option that we have is graph 3. And some notes you might include to remember why you identified graph 3 is just maybe to say that steady is equal to straight line, right? Or steady is equal to consistent data. Great. So then our next statement, statement B, says you walk slowly at first and then increase your walking speed. Increase your walking speed. So as you start out with the graph, the line of the graph should be low to the x-axis. Low to the x-axis means not a lot of distance is passing as time is passing. And then you increase your walking speed. So there should be a piece of the line that quickly curves upwards. So I think our option here is graph 4. So if we take a look at graph 4, we can see that there is that really great example of walking slowly at first, which is the bottom piece of that line, and then increasing speed. Remember, our time is on the x-axis and distance is on the y-axis. So the more vertical the line, the faster they're traveling. The more horizontal the line, the slower they're traveling. So there is the point in the middle of this data where they go from kind of being slow to working quickly. Statement C says, you walk rapidly at first, pause for several seconds, and then walk an increasing rate for the rest of the trip. Now, anytime that you say that the data, there's a pause in the data, you're looking for a horizontal location. In our information, we have 2 graphs with horizontal location, and that's graph 1 and graph 5. So at this point, I'm really not comfortable making a decision on which graph I'm going to go with for part C, so I'm going to move on to part D. Part D says you walk at a steady rate for 3 seconds, pause for 2 seconds, and then walk at a steady rate for the rest of the trip. So there's actually a couple of important things in this statement. The fact that it's a steady rate and the fact that there's a pause. So the pause represents the horizontal line. And a steady rate, as we remember, represents a straight line or consistent data. So I'm going to take that statement and bring that right back down here as well. So steady is a straight line, and also a pause is a horizontal location in the line. Right, so both of these things are important for letter D. And the only graph that I can see that has our pause, in addition to having straight lines on either side, is going to be graph 5. So we'll pull graph 5, and that goes with our letter D. And that actually leaves us with, just by process of elimination, graph 1 for letter C. And again, we talked a little bit about those curved instances within the graph that help us in deciding whether they're increasing or decreasing. So if you look at graph C, there is this point here where the graph is more vertical, so you know that they're traveling rapidly. And then there's this point here where the graph starts to become a little more, it's still an increasing rate. The line is more vertical than horizontal, so that's the key piece to those lines. Letter E says you walk rapidly at first, but gradually slow down as the end of the trip nears. And of course, what we have left is our graph 2. But more importantly, we know that the line at the beginning of graph 2 is more vertical, which shows an increase of speed, and the line towards the end of graph 2 is more horizontal. So right about here is where our data changes, and that's kind of how we know that they're going from a faster pace to a slower pace.